Coffee, Cows, and Crops is produced by the Peace Country Beef and Forage Association and hosted by Extension Coordinator Johanna Murray. On this podcast, we discuss management practices and research results with scientists, ranchers, researchers, and farmers. We strive to share innovative information and farming practices supported by sound science and practical wisdom. So grab a cup of coffee and let's get learning. Hi everybody, thank you for tuning in to today's episode of Coffee, Cows, and Crops. Today I'm talking to Melissa Werkema, the owner and manager at Future Analytics Lab in Red Deer. And we're going to talk today about the use of plant sap testing and root exudate soil sampling, which is pretty cool. But before we get into all of that, Melissa, can you introduce yourself and maybe a little bit about how you got into doing these sorts of analyses and that sort of stuff?
Sure. Good morning, everybody. Melissa Werkema from Future Analytics. I started my education approximately 12 years ago in BC at BCIT. I started off with a chemical sciences diploma at the British Columbia Institute of Technology. And that was a 4-year program, basically crammed into 2 years, 8 courses every semester, and that's 8 courses plus 8 labs. So it literally threw me into hands-on experience with lab equipment, everything lab oriented. I knew right as a little girl that I wanted to do chemistry, and found out very quick that I wanted to be in a lab very quickly. So that's why I went into this chemical sciences program, completed that program, and shortly after, it took about a month, I got my first lab job as a lab technician, doing pesticide, herbicide testing for fruits, veggies, honey, processed foods, for a ton of things right in Burnaby, BC. It was about 2 years in that position. I decided, just the crazy me, to hop on a plane and take part in a huge archaeological dig right in Jerusalem in Israel. And from there, I met professors from Tel Aviv University and the Heidelberg University. And I mainly helped with, in the morning, with the dig, and then later on just doing the residue chemistry to just see what was in the artifacts and what they were cooking with. And that obviously came into the oils and the plants and whatnot. From there, after a few weeks on that dig, a few professors from Tel Aviv University had found out more that I loved the lab work and how good I was at the lab work. And they suggested I contact the Weizmann Science Institute in Rehovot, Israel. And so finished the dig, went back to BC, and it took me about a month. I was only back in BC and emailed the Weizmann Science Institute. And a professor there had been looking for somebody to build up a reference library for over 40 plants and herbs grown in Israel and Europe. And he asked if I wanted to be that special person to build up this reference library. And in a heartbeat, I took the project. He flew me out there, paid for my accommodations, and it was supposed to be for 6 months. It ended up to be 3 years. I built up the reference library, and in the meantime decided to attend university there to just further expand my knowledge. And that research project was huge. That's where I've gained most of my information for what I do now. So I came back, I worked a little bit in industry, and I couldn't stand it here. So I started my own lab, and that's where I'm at. I found out quite a few of our testing, even our greenhouses, were going to Ontario every week, which I thought was ridiculous just for our water. So hopped in there. I do all our water testing for our greenhouses. And then sap analysis came, and to me it was so simple to do sap analysis because that was just the base of everything I did in Israel. It goes much further ahead than just the nutrients that are shown. So do sap analysis for the greenhouses and all the farmers, and off we go for good solid base, I think, for testing. And then obviously the soil ties in as well.
Right on. So I'm not super familiar with plant sap analysis. So what are some of the things that you can learn from that? What sort of information comes out of a plant sap analysis?
Sure. So sap analysis, there's two types of sap in the plant. There's your xylem sap and your phloem sap. So how we understand sap analysis is the xylem sap, and that carries all of the nutrients through the plant. The phloem sap carries more of your sugars, proteins, and amino acids, so more of your complex structures. So the xylem sap is just the pure sap flowing through a leaf, and there's interactions going on within the plant between the new and the old leaf. Some being in that the minerals, there's 4 of them that are extremely mobile, and then some that are medium immobile, and then your immobile nutrients. So a SAP analysis just shows you whether you're deficient or if you're sufficiently, if there's enough nutrients available. It just gives you a snapshot of the nutrients that are in the plant in that moment. So you can make adjustments quite quick.
Cool. So how do you take samples and like what parts of the plant do you sample to get that sort of sap out of it?
So it's just the leaves. It's just the leaves of the plants. There's different types. There's your petioles as well, but I actually take off the little stems or the petioles, so it's just the leaves themselves. And again, it's just the new and the old leaf from any crop. Yeah, just the leaves themselves. It's that easy.
Nice. So plant sap analysis, you can get what nutrients are in your plant really quickly. So, and can you detect stuff like this is going to be a little bit off base probably, but if you can detect like different nutrient deficiencies and stuff, can you also detect things like pathogens with this test?
No, pathogens is a completely different aspect. So SAP will just mainly hone into the nutrients, but then the phloem SAP gets a lot more detailed in with the amino acids, your protein, your sugars, and there's several of those that can be listed. So it's mostly just the nutritional side of everything. When it comes into the soil, it really there's more tie-ins with the soil as well, with the extracts being used and how it interacts with the plant itself and how those nutrients are taken up. But again, just from the nutritional side.
Right. So on that note of the soil, I know root exudates are really kind of localized around the roots. So how do you take those soil samples?
So that has a lot to do with the residue chemistry that I worked with in Israel, and every plant will leave behind a residue or a certain type of trademark, which can be traced to an organic acid. And a lot of those trademarks here, I find in Alberta, is a lot with oxalic acid and citric acid. And so I'll make my solutions as part with using those organic acids. And that's just what the plant has released into the soil and what the soil already has.
Okay. Do samples have to be taken as a specific way to be more or less effective when you're trying to detect those exudates?
Yeah, I like a probe. Most farmers sample with a probe. I get quite a bit more accurate results there. A few of them have sampled just by hand, and by fluke, they've taken soil samples that have been where a collection has occurred of whatever they've applied. So levels seem to be extremely high. for nutrients, any kind of nutrients. So a probe usually, if you go the circumference around a field, it seems to be a bit more accurate than you're not just scooping with your hand and getting a general idea of where everything is at.
Okay. So what sort of information do you get out of a root exudate test as opposed to the plant
So
sap
the
test?
soil test will give you a baseline of where your soil is at, nutritional wise again. It's really important from the soil. I also measure a carbon number and the microbial respiration rate, and also 2 forms of the nitrogen, which is at the top part. The carbon number plays a critical role in the balancing of the SAP report. So in a perfect world, we want all nutrients in a SAP report perfectly balanced. We don't want anything too high or too low. So the better carbon number you have in your soil, the better chances based on the application rates that you add onto your crop, the better uptakes of all those nutrients will be dependent on your carbon number. So if you have a low carbon number in your soil, it will take quite a bit more nutrients to add in to become absorbed into the plant, and that'll be reflected in the soil as well. So if I get a soil report that has an average or low carbon number, they could be very well high in iron or manganese or calcium even. And if that carbon number isn't sufficient, you'll start to see imbalances. So right away, I look at that carbon number in the soil.
Right. And that's often organic matter, right?
Mm-hmm. Mm-hmm.
Right. We talk about that a lot at PCBFAs. If you have an issue with your soil, organic matter is a good place to start.
Yes, and it's important you get higher organic matter through a better carbon number. It all plays into a bigger picture. Something really neat too: sulfur, nitrogen, and phosphorus. Also selenium. I know selenium isn't really, and I don't measure selenium in my soil, but all of those are bonded to carbon in the soil. So especially your sulfur, nitrogen, and phos. You have 2 forms of your phosphorus. The one is readily available, but then phosphorus also it's an adsorbed form where it's kind of like a reserve, a bank reserve of phosphorus. And that phosphorus will then be released, again, dependent on your carbon number.
Right.
So we all want phosphorus. So you could have a lot locked up in there that could come out over time, as long as you have a good carbon number.
Interesting. And I want to circle back a little bit. You mentioned earlier that there's some nutrients that are really highly mobile in the plants and some nutrients that aren't. Do you want to talk about a bit about which nutrients do move around a lot and which ones are immobile and kind of what that means?
Sure. So we'll start with the easy ones. The only two immobile nutrients are calcium and boron. So in a SAP report, in a good SAP report with good moisture and sufficient levels, you'll always see calcium and boron start off low in the new leaf, and it'll just continue to build and grow higher in the older leaf as the season continues. And calcium can be considered the engine oil of any plant. So the better calcium you have in the plant, the better come through of all of, especially your micronutrients. And as long as that one is moving from low to high, so low in your new, high in your old, then you have a good plant. So that's calcium and boron. There's quite a few medium immobile nutrients, and that's your sulfur, manganese, zinc, iron, copper. Oh, there's quite a few in there. I have a chart. Those will depend on obviously how good your calcium is to move through. And then your extremely mobile nutrients are potassium, phosphorus, nitrogen, and magnesium. Those will literally just flow through the plant very quick. They're extremely mobile. So that's why in quite a few crops, the nitrate farmers add nitrate 1 week through a foliar application, I'll see a huge increase in the nitrate through the sap. But then in a couple weeks, it'll start coming down again. And that's just because it's so extremely mobile through the plant. Potassium is also extremely mobile, and that's hugely affected by the reproduction. So right now in our growing season, potassium is under such huge demand. So you'll constantly see the new and the old leaves fluctuate. Most of the time you'll see the new leaf be higher than the older leaf in a sap, and that's because every mobile nutrient, so those 4 mentioned, the new leaf will constantly take it from the older leaf. So the old leaf will be like a reserve bank, and that will do that for nitrogen, magnesium, potassium, and phosphorus. So to keep adding those is no problem because they're so extremely mobile in the plant. And if you let it go, you'll always see the old leaf will start to show color deficiencies first in a deficient case because that old leaf is its reserve, and the new leaf just continues to take from it. So
right.
I do have a chart as well. So it's a lot of information, but I do have charts to show which is mobile, medium immobile, and then extremely mobile.
Right. That makes sense. And when we talk a lot in forage production about nitrate poisoning, because if certain plants freeze at inopportune times, we can get a lot of buildup of nitrates, which can be toxic to cattle. So how does that work with those really mobile nutrients when the plants go dormant or when frost happens? When do those nutrients stop moving around, I guess?
Yeah, well, that's probably why it's so important to see a SAP report, so you're not adding too much, so you're not overloading that system, so there isn't a chance of that toxicity happening. So that would definitely be a benefit to know how much is in there. The microbes would definitely be a critical role in that as well. How much the microbial activity is in your soil, it could help decrease everything. But if there's such a large buildup already and too much has been applied, I would think it would just take time for that to come down.
Right.
And I've already had some farmers cutting back quite a bit of rates. They've already cut back 20%, thinking would be enough. SAP report came back and they could have cut down an extra 20. That just to give you an idea of how much over excessive nitrate we're adding into our crops. It seems to be quite a shock to some farmers on the lesser amounts, but most of the time it's lesser amounts of nitrate or nitrogen, but increased rates of potassium, especially now, or iron or zinc, or anything to increase. And that's just what the SAP report is showing. So it's kind of a different way of thinking and farming, but hopefully saving money in the end. That's what we're all about.
Yeah. Fertility is the expensive thing.
Yes, and it's time to cut back rates and get healthier soil too, and
Yes.
save money in the process.
Definitely. So that being said, once the plant has gone dormant, if it does have those high nitrate levels after it's already gone dormant, do those nutrients and nitrates continue to move, or once the plant goes dormant, are they kind of just static there?
I would think they just stay there, especially if it freezes. It's not going to do much. It's in the spring when everything starts moving, then I think everything would start quickly dropping quite a bit. But whatever you apply in the fall, whatever is there in the winter, it's not going to move that much, I don't think. I would need to see data to prove. I hate, I could probably read a ton of papers saying, well, one paper said this and another paper said that, and how do you know? But I come from the standpoint, if you want to see it, then send me some soil and let's see what we find. And the answer is always in the data, I think, and good data.
Yes.
So it could be a neat thing to track to see what that nitrate is doing throughout the winter. And the microbial activity definitely goes down. So couldn't really track that to the microbial respiration, but what it's doing in the soil and where it's going, that would just need to be tracked here.
Right.
To see exactly what it's doing, because our winters are so cold.
It's true. Interesting. Okay. What else did I have in my notes here? So this one's not in my notes, but I was reading a paper here, speaking of research, about legumes and rhizobium bacteria and all that sort of stuff. But the paper was saying that rhizobium don't like acidic soils, but if you can find legumes that are tolerant, the root exudates can actually change the rhizosphere to be more hospitable to those bacteria. Is that something you can detect in those root exudate samples and that sort of stuff?
That's exactly, because each root exudate will have a pH around 3 or a 4. And you're never going to change that. That's just at the pH that they're at. But the huge gain of using those root exudates, especially in the soil, is even though they all have a pH that low, each of those organic acids have a function to them. So your oxalic acid will actually help recruit those beneficial microbes to the actual root structure to bring those nutrients back up into the plant. Whereas other organic acids will help recruit the proteins or amino acids. So each of those organic acids plays a critical role into actually bringing the nutrients back up into the plant, regardless of the pH, because you're never going to change the pH of an organic acid. It's just, that's how they occur in nature. But it's the role and the function of each of those organic acids that play critical roles. And that's why they need to be focused on more. And Alberta luckily has, as I said before, a lot of oxalic acid. We have very high amounts of oxalic acid in our soil, which is highly beneficial, because then it's helping to recruit quite, not all, but a good portion of the microbes that are in our soil. If you have a good amount of microbes present, then the oxalic acid will be very beneficial. And the healthier the soil, then you'll start to see more of the maleic and malic acids, and that will really play more into your proteins and amino acids as well.
Interesting.
So a general soil that's not as healthy will just have more oxalic acid, but I see more of our organic growers start to have more of the malic, maleic, palmitic acid has come up. Very rare, but I've seen it come up. And there's one more, citric acid will come up.
Huh. That's really interesting.
So it's neat to see, and I can always tell when I run the scan of the soil and I see what organic acids are in there, how healthy that soil is. And then you make that soil solution to those organic acids, and then you know what nutrients are in there that are currently available to the plant.
Mm-hmm.
So as compared to our industry labs, they'll use strong acids, which is mostly your sulfuric, hydrochloric, nitric acid. You won't find those acids in nature and in soil. So by adding those stronger acids, one of the main reasons why that alters data so much is most of the time it will make a number seem much higher than what it actually is. And you don't know exactly what's there if you're adding such a strong acid. So it changes the form of all the chemistry. And it also seems, or it makes it look like some numbers are higher than what they actually should be.
Interesting.
3 years of work in Israel.
Yeah.
But you guys get me now.
Nice. All right. I think that's all the questions I have for now. For anybody who's listening who's interested, do you want to list like your website or any resources or anything like that before we sign off?
Sure, I have a very basic website and I will update it when I have time, hopefully this fall when the mad rush is over. But it's, you could just Google even, or DuckDuckGo is a nice private search engine. I use DuckDuckGo now. Just look up Future Analytics or Plant Sap testing and I should pop up from anywhere. But if not, it's futureanalyticsinc.com is the website.
Perfect.
And just email or call me. I don't mind anytime.
Awesome. I will put that link there in the description of the podcast. And yeah, on that note, we will sign off for today. And yeah, thank you very much for coming on.
You're welcome. My pleasure.
Peace Country Beef and Forage Association is a research and extension group based out of Fairview, Alberta. Our mission is to help producers thrive in an agricultural system that is profitable, regenerative, and attractive to future generations. To learn more about what we do and see the results of our research trials or our archive of newsletters and fact sheets, check out our website at peacecountrybeef.ca. Want to get in touch? Have a burning question or a topic suggestion? Send us a message on Twitter, Instagram, or Facebook. Thanks for listening.